furnace types, construction, and efficiencies. In HVAC, there are several and many different types of furnaces out there that you're going to run into. They're going to have different construction. They're going to have different guidelines that we're going to have to abide to properly put them in. So furnace types and constructions, the type of furnace that are designed is based on the type of fuel that's being used. It's going to be based on the space that's going to be available to us in order to put it in. It's also going to be based on what type of heat transfer medium are we using. Is it air? Is it water? What are we doing to accomplish what we're trying to accomplish? The heat transfer medium, it could be a warm air furnace. It could be a hot water boiler. It could be a steam boiler. Okay, but we have many different types of construction that's out there that we're going to run into. And we really have three most common types of furnaces that we run into, and those are your upflow, your downflow, and your horizontal. Your upflow furnace really is the most common type due to building construction. Okay, it takes air from the bottom and draws it up through the heat exchanger and then back out. Okay, it uses an induced blower motor, which increases the furnace system efficiency, and it forces air through the heat exchanger into your ductwork. Sorry. So as we go through, our downflow furnace is also referred to as your counterflow furnace. Okay, your counterflow furnace is all of your stuff that maybe you might find in maybe a trailer park, something maybe where it has to run the ductwork through through the floor or something like that. But these types of furnaces, they force the return air from the top of the furnace downwards through the heat exchanger and then now maybe through the floor. Okay, horizontal furnaces, they're also going to require air to flow horizontally through your heat exchanger. The return air is pulled through the end opposite of the heat exchanger, and all furnaces types require installation of a cold air return to supply the furnace with air to be reheated or recooled. Most of our furnaces are going to be constructed of some sort of steel, and your blower compartments are going to be lined with insulation to help reduce your heat loss or heat gain, and also to reduce the noise that the blower will be making. The section is also provided for installation of your air filter. We will also have a safety interlock switch that is going to be provided, and that's going to be usually installed on the blower access door. So anytime that door or panel is actually opened or removed, it's going to de-energize the entire electrical system for that particular furnace. We call that a safety interlock switch or a dummy switch in many cases, because we want people, especially the homeowners, not to be messing around with the electronic devices, especially if they are not qualified to. So the door switch needs to be engaged in order for the furnace to be on. So in other words, the blower door needs to be put on or put back onto the furnace in order for it to actually start up again. Newer furnaces out there in regards to efficiency, we have very high efficiency ratings today. These furnaces use less fuel but produce more heat. Okay, all of our furnaces have a measurement of efficiency, and they are measured in the AFUE rating, or Annual Fuel Utilization Efficiency Rating. And what that does, it compares the yearly or annual energy output to an annual energy input. The higher the AFUE rating, the more efficient and cost-effective that furnace can be. By federal standards, though, we have a minimum efficiency standard of 78% AFUE, which means every furnace out there that's being manufactured cannot be any less than 78% efficient. We have furnaces that are up to 95, 98% efficient, which means that 98% or 95% of the heat that is being generated by these furnaces are not being wasted or not going out the chimney. It's actually being used to heat a space, heat the home, heat a building. Okay, higher efficiency furnaces have a rating above 84% efficient. So if we looked at this chart here, if we were at a home and we found that we had a standard efficiency, low efficiency furnace, say, well, I'd be at like 65% efficient. They would be running a annual energy cost, operating cost of probably around $400, maybe $500 a piece. If I can go back to that, about $500, we'll say. About $460, maybe $550 for the year to operate that furnace at, say, 65%. But if we were there and we were to sell them or give them the option to put in a 95% efficient furnace, we are cutting down on their energy cost by over $100. That's where a lot of our standards are coming from. Everything is coming from energy efficiency. So we want to see furnaces that are outdated be replaced with newer stuff, because we are trying to save on energy costs and bring yearly operating costs down to a more manageable thing. Your high efficiency furnaces may contain a couple of different varieties. They will have an improvement in the flue pipe routing. They are going to have a high heat transfer heat exchanger in them. They are also going to have a secondary heat exchanger in there. And that secondary heat exchanger extracts as much heat as possible from the system. The temperature at which the flue gas is emitted to the atmosphere is also greatly reduced. Reduction of that flue gas temperature results in condensation of water vapor, hence the term a condensing warm air furnace. It is that condensation of water that we are generating by lowering the flue gas temperature before it exits the furnace is what gives that furnace the efficiency that we are looking for. Your high efficiency furnaces can also be ran with PVC piping for their flue gas. We no longer need to have metal because the flue gas temperature is so low. We're only talking maybe 100 degrees, if not lower in some cases, depending on the actual piece of equipment. We can look at this picture here. You will see that we have a flue pipe, a connection here and a connection here. With a lot of our high efficiency furnaces, you will come and see that there will be two PVC pipes that are going to be connected to this particular type of furnace. You will have a fresh air intake, which will be sucking in air into the burner compartment of your high efficiency furnace, but you will also have your flue pipe, which will be exiting your furnace. So as this burner happens to be igniting, we are now introducing fresh air into the furnace to help with combustion. We are now ensuring that we are burning as much of the fuel as possible when the burner is operating, and any of the residual flue gases that have accumulated will now be exiting the flue pipe at a much lower temperature. Mid-efficiency furnaces have an AFUA range of anywhere between 79 and 83%. They use high heat transfer heat exchangers with induced draft motors, just like your high efficiency stuff. They usually have a flue gas outlet of only 3 inches due to the heat exchanger design and degreased combustion products. They are also used on Class B type chimneys or approved flue chimney liners. However, it depends on the local municipalities and codes, where we have to look and see whether or not we can or cannot install these types of furnaces into an existing chimney. If the chimney is not capable of handling it, we cannot use it. We will have to use other means to ventilate these types of furnaces. They may be low profile and installed horizontally or vertically. So we have the ability to manipulate these types of furnaces to put them into areas that are best suited for the customer. Okay, also note, all furnaces are installations must conform to the recommendations of the manufacturers, and we must follow our local and international mechanical and fuel gas codes. We cannot just take a furnace and put it anywhere we so choose and put it in as we feel like. We have to be following codes and the manufacturer's recommendations in order to safely put these in to minimize risk of damage to the homeowner, the equipment, and obviously ourselves. Your mid-efficiency furnaces are going to vary from high-efficiency furnaces due to the lack of a secondary heat exchanger. Our older style furnaces may only have one heat exchanger, and with that only one heat exchanger, our efficiency greatly drops. The chimney for exhaust gases may also vary. Okay, hot flue gases are sent directly through the chimney, and much of the heat energy is lost. The more heat that we lose through the chimney, the lesser the efficient the furnace is. Your heating sections are going to consist of your burners, your steel heat exchanger, and your venting system. That is what consists of what makes the furnace produce the heat and deliver it to the space without sending unnecessary harmful gases into the space. The heat exchanger is the section of the furnace that gives us between life and death. It is the only piece in there that protects the homeowner from the products of incomplete combustion. The venting system is what sends all those incomplete products of combustion and harmful gases out into the atmosphere. So the sequence of operation of our furnaces is pretty much as follows. We have to have a thermostat. The thermostat has to call for heat. The gas valve is now going to be opened. Gas flows to the burners, and an ignition spark ignites the gas. The flame warms that heat exchanger, and in turn warms the air. And the hot gases from combustion are collected at the top of the heat exchanger and is then routed out to a vent. Your high-efficiency furnaces or your condensing gas furnaces are really what is on the market today. Because, again, we want energy efficiency. Those are going to have an AFUA rating of anywhere between 84% to 95%, if not more. Okay, those components are going to have your flue piping, your heat exchanger, and your secondary heat exchanger. The secondary heat exchanger can be found down at the bottom. And if we were to take a look at the heat exchanger, it would literally look like a coil, like a condenser coil or an evaporator coil. It's going to be a bunch of pipes routed through, and it's going to be covered in aluminum fins. So as the flue gases go through that secondary heat exchanger, we are picking up additional heat to deliver to the space. And in turn, we are lowering the flue gas temperature down to 100 degrees or so. Your outside air enters through a PVC pipe running through the wall or a roof. Okay, because remember, on your high efficiency furnaces, you are going to have two pipes. One that's going to be drawing outside air into the furnace to help support combustion, and you are going to have another pipe going out, which is going to be our vent pipe, which is going to be sending all of the products of combustion and flue gases out into the outside area. A traditional chimney main is not needed. Exhaust is through a PVC pipe running through a wall or a roof. The operation of these types of furnaces is the gas flame heats the primary heat exchanger. The combustion blower draws the hot combustion gases through that primary heat exchanger. The hot gases produced by combustion are drawn down by the combustion blower motor into that secondary heat exchanger, where latent heat is now exchanged. That's going to lower the flue gas stack temperature and condensing water vapor, where we are now able to send that cooler gas out into the atmosphere. The indoor blower is going to force the circulated room air across the primary and secondary heat exchanger. The air picks up that latent heat of vaporization from the flue gases, and the hot air created by the secondary heat exchanger is then circulated through the furnace duct system. Your exhaust gases are low in temperature and vented outdoors through the PVC pipe, and your primary air for combustion is introduced from the outdoors through PVC piping. Okay, your high efficiency home heating systems that provides both space and water heating, those are going to be rated according to a combined annual efficiency ratio or CAE. And those type of systems is the complete heat system. And those can have a rating of about 90%. Okay, systems produces 3 or 4 times more hot water than your conventional water heater. Okay, these can be vented either vertically or horizontally with a simple 2-inch PVC pipe. Your outdoor air is used for combustion, just like a standard high efficiency furnace. And these systems are going to contain 2 modules. It's going to have a heat module, which acts like a storage area, and it's going to have an air handling module, which provides comfort conditioning for the home. So in other words, these types of integrated systems, they are going to be used for both your heating of a home and providing hot water for the home. The operation of these types of systems is on a call for heat. The pump and the air handling module draws hot water from the heat module and circulates it across and around. The heat from the water is then transferred through the use of a heat exchanger and a blower. The water then returns to the heat module where it is reheated. The hot water for domestic use comes directly from the heat side or the heat module. Okay, 2-stage furnaces, they feature 2 levels of heat. Okay, they can consist of a modulating gas valve, which will ramp up and ramp down based off of the demand inside the house. Okay, they adjust the output based off of the demand. Majority of the operation is in the first stage, or what we consider low fire or low heat. The low heat stage requires less energy consumption and offers greater efficiency and provides greater cost effectiveness. On colder days, the furnace moves to a higher heat or a second stage situation, or what we call high fire. That motor adjusts automatically to meet the changing needs. In those two stages, heating reduces the temperature swings, and it provides a more consistent and comfortable temperature within the space. Your variable speed indoor blower also will modulate up and down based on the demand, and it creates a more consistent airflow, allowing the air filter to trap more impurities, thus improving the air quality indoors or inside the space. Your modulating furnaces can provide ratings between 40 and 100% of the total capacity. A solid-state integrated furnace control initiates and manages the sequence of operation on what is going on. It communicates between the circuit board and the thermostat. The circuit board now gets the signal to tell the burner and the blower to either ramp up or ramp down, depending on what the thermostat is sensing inside the space. Okay, and these units automatically choose the most efficient blower speed. Unit heaters, these guys are going to be found in a lot of your commercial buildings and factories to heat only certain rooms and spaces. Okay, they may operate either on natural gas or propane. And a polished reflector radiates the infrared energy that is converted into heat as it reaches the occupants and work surfaces. Okay, what you have here is what we call a radiant heater. It's only going to heat up solid objects in the space. It's not going to heat up the air. It's only going to heat up solid structures within the space. Another form of ways of energy efficiency. The surrounding air becomes warmed by conduction and convection. Okay, unit heaters are available for downward warm airflow, and these provide high velocity airflow anywhere between up to about 2,500 feet per minute, or FPM, against larger door openings. They are usually mounted 3 feet above or 4 feet away from the opening, and the unit is operated by a door switch or thermostat connected in parallel. Your areas that are critical in venting a lot of your furnaces and equipment is the furnace capacity, the type of piping that's being used, airflow, the blower itself, the length of run, how far away does the furnace need to heat up, your heat load, depending on how cold it is outside and inside, the number of turns or the number of elbows in the ductwork or in the flue pipe itself is going to play a critical part in how well a furnace actually ventilates. Also, following the recommended manufacturer's recommendations also real critically affect how it vents. Okay, those YouTube certified individuals out there who want to just try to do things on their own may affect the efficiency and the venting capacity of a furnace. And obviously, if you do not follow your local code and international mechanical and NFPA fuel gas codes, yeah, that's also going to affect the way a furnace operates. Okay, the flow of a chimney gas out of the flue or chimney affects the heating efficiency. Fuel losses of anywhere between 4% and 15% is possible just by simply having a messed up flue pipe. The chimney or vent pipe should extend at least 2 feet above the highest part of the roof to prevent backdraft in the chimney or vent pipe under windy conditions. If you have a messed up flue pipe and you have a backdraft situation, that will cause the flame inside the furnace to roll out towards you or roll out away from the furnace. We do not want that to happen. The combustion gas flow is affected by the pressure difference between the combustion air entering the furnace and the combustion air leaving the flue or chimney. Pressure in the building or atmospheric pressure and the temperature of the combustion gases also affects the flow of your combustion gases. Okay, exhaust gases are removed from a conventional furnace through a vent system consisting of a flue pipe, that is joined to the chimney, which is vented to the outside. Okay, flue pipe reaches temperatures of anywhere between 500 and 600 degrees on a conventional on a conventional furnace. The efficiency of the furnace is reduced by 30 to 40% because of the heat exhausted out of the chimney. So when we are thinking about our chimneys, we have two types of chimneys out there. We have a Class A, which is basically our masonry chimney, and we have our Class B chimneys. Okay, those are our double wall metal type. Okay, as we see, as shown here in the diagram. Your PVC pipes, they have to follow a strict code. Okay, if we can look at our diagram here, our combustion air that is being sucked in to our furnace needs to be lower than our exhaust. And if it is penetrating through a roof line, that exhaust needs to be facing downward. The reason why it is facing downward is because we do not want any sort of foreign matter to be sucked into the furnace. However, that does not always prevent everything from happening, because, you know, we do have bees and hornets' nests that do like to make nests on the end piece of these types of pipes. But we also do not want any sort of flue gases that are exiting our exhaust vent to be recirculated back in to our flue pipe or into our combustion air intake. When we are putting these in, we have a couple of codes that needs to be followed. First off, our flue pipes need to be pitched 1/4 inch per foot towards the furnace. Okay, we also need to have a condensate line that needs to be installed so that we can drain any sort of condensation that may have accumulated inside the flue pipe. We also, if we are supporting it on any sort of way, especially horizontally, we need to have a support of every 5 feet in order to properly support these types of furnaces. Okay, any sort of metal flex liner, these have to be inserted into the entire length of a Class A chimney. We just cannot take these types of flue pipes and just stick them into a regular chimney. We do need to put in a chimney liner in order for them to work. And that's what a chimney liner would look like. It's a clear, unobstructed chimney is necessary. Any tar or creosote has to be removed. Check the chimney for any cracks, loose or missing bricks, and make repairs as necessary to provide safe internal and external conditions. And if it cannot be done, the chimney needs to be replaced. Chimneys must provide at least a half-inch space between the liner and your masonry inner wall. The proper liner dimension must be used to ensure good exhaust. Always check for proper venting following installation and startup. So you would actually do a combustion efficiency test to make sure that you do have the proper draft going up the chimney, and make sure that we are exiting and releasing the proper amount in order for this to work properly. High efficiency furnaces do not require a traditional chimney. Your flue gases leaving the furnace can be anywhere between 115 and 118 degrees, much lower than your standard conventional furnace. These exhaust gases are vented outside through PVC pipe. Your outdoor air brought into the combustion chamber is also brought in through PVC pipe. A furnace may be vented either vertically or horizontally. It could go out a roof or it can go out an exterior wall, whatever works best. When venting a furnace horizontally, manufacturer's procedures must be followed. Venting pipes should follow the shortest route possible with the fewest elbows. The trick of the trade is to try to keep your flue pipes as straight as possible using as little fittings as possible. Intake and exhaust vents exiting a sidewall must be as accurate as possible as well. A drain line is necessary for disposal of any sort of condensate. If we do not do this and we do not follow these simple rules, we are going to run into problems with ignition. A lot of our high efficiency furnaces today have pressure switches, sail switches, all sorts of safeties in there. If we are not properly draining our flue pipes and our furnaces, we may run into a problem where a pressure switch may not close properly to send the signal for ignition. Furnaces must be individually vented, not combined with any other appliance. Okay, PVC connections must be leak tight. We must be using PVC primer and PVC glue to properly make the connections. And if it is penetrating through a sidewall, our intake is always facing down. Our exhaust is always facing straight out. Other things that you may run into when you're coming into Class A and Class B ventings, you may run into a bimetal damper. Those may be installed on your flue outlet openings or as a section of a flue pipe. These are usually either thermally operated by a thermostat or usually require no motor or switches. Okay, a vent damper may be electronically operated and wired to open on a call for heat. It closes when the thermostat is satisfied. Usually when you see these things inside a flue pipe, those motors are wired in parallel with the W wire. So once the W wire, once we get the call for heat, it sends the signal out to the motor. Motor opens up the damper, which will then in turn send the signal down to the ignition module or what have you to begin the ignition sequence. Okay, you may also run into makeup air units as well. These help solve negative air pressure problems in tightly constructed homes. Okay, they build up a slight pressure in the home, which prevents infiltration around windows and doors and also eliminates draft. Some are required by code and regulations in many states. It also improves your furnace efficiency by providing proper air for combustion. It delivers fresh air to the furnace, and the air is then cleaned by filters, heated or cooled as needed, and circulated throughout the duct system.